Hello dear students, I welcome you all once again on Wallah English YouTube channel, and today we will discuss about the static intimacy part, guys. And you know that in yesterday class we have discussed about the various type of support, what are the various type of support we have, and how many external support reaction can develop in case of 2D support and in case of 3D support. So this particular concept we have already discussed in previous class, kindly cover it, and then after that guys you can join this particular session in which we will discuss how to master basically the static indeterminacy of any kind of structure, whether it is rigid jointed structure or pin jointed structure. So you know that guys, in case of static, first of all we should know what is basically static indeterminacy. I will define it in detail, but before that guys, let me tell you one thing, right? As you know that what is determinate and what is indeterminate structure, let me explain with a very simple example so that you can understand it very well. Okay, so guys, if we talk about the determinate structure, it is very simple, or you can say that this particular structure can be analyzed completely by using static equilibrium equation alone. That means you are able to find out the external support reaction, you are able to find out internal reaction also, right? But let us suppose guys, if you have any structure in which the static equilibrium equation is not sufficient to find out all the reactions, whether it is internal reaction or external reaction, then in such situation you need some extra equation which will be helpful to solve such type of structure, and in that case that particular structure is known as indeterminate structure, right? Izan, hello, how are you? Come fast and join the session guys. Okay, so now I think this is the basic difference. Now you are able to understand what is the difference between this fundamental difference between the indeterminate part and determinate part, right? But we will discuss this particular thing in detail in our session also. Okay, okay guys, let us start it. So I have already shown you the complete roadmap of our fast track course. So Parakram Gate ASC 2025. Okay Akram. Okay guys, so in our today's session what we will discuss basically, so let me tell you about it, okay, quickly. So we will discuss the static equilibrium equation. This particular part we have already covered guys. Kindly watch the previous video or the first video, right, in which we have discussed the various type of support. This point we have already discussed. Sir, aapse hi padhna hai structure. Thank you so much. I will definitely teach you the structure analysis in detail, and it is my guarantee you will solve each and every question which is related to this particular subject, right? Because that is our aim only, right? The next thing is we will discuss what is static equilibrium equation and what is static indeterminacy external. That means what is external static indeterminacy for a particular structure, right? Similarly, we need to understand what is internal static indeterminacy, how to find out the internal static indeterminacy of a structure also. Okay, so these are the points which we need to discuss in detail in this particular class. And I already told you guys this particular thing. This particular class is, or this particular series is a fast track course series in which we'll try to cover the important part or major part of your structure analysis, right, in a short duration, like a 10 to 12 class, right, so that each and every student are able to understand the concept which are important for our gate examination purpose, and they are able to solve the problem also. Okay, but still guys, you need to make some extra effort from your side also, so that you can solve some new concept, new question also, right? That is the requirement from your side also. Okay, okay guys, so let us start our concept part over here. So this portion is already done. We are approaching the static equilibrium equation. Okay, okay guys, now static equilibrium equation, let me tell you about this. What is static equilibrium equation? If you want to read this particular statement, you can read it, but let me explain in a very short and in a very detailed manner also, you can say that, right? So let us suppose guys, if you have any kind of object, let us consider this is our object. Okay, let us take this as our object. Now what will happen if I apply a force in this particular direction? Let us consider this force is some 5 Newton or 5 kilonewton. You can take any unit, that is your choice. Okay, I'm just explaining the concept over here. So let us consider if I apply a certain force on this particular object and there is no reaction to resist it, then what will happen? This object is trying to move in the horizontal direction easily, right? Okay, sir. That means it is not a static one. It is not a static one. But let us suppose, guys, if you apply a force which is basically 5 Newton over here, and you are trying to put a support or a reaction at this particular location, so what will happen? The same amount of reaction will develop at this particular end, but in opposite direction. Now what will happen? This object is not able to move in the horizontal direction. Why? Because there is some action as well as reaction, and both are equal and opposite. That means they are trying to cancel each other. They are trying to cancel their effect basically, right? So ultimately your object will not move anywhere. So in such condition, can I say that it is in static condition in the horizontal direction, because whatever force you have, the same amount of reaction is developed in the horizontal direction. And due to that reason, this particular structure or this particular object is stagnate at this particular location, right? That's why it is in static condition in the horizontal direction. If I apply the same type of concept or same type of approach in the vertical direction also, so in such condition it will be in static condition in vertical direction, sir. Let us suppose if I have moment reaction which is basically like this. Okay, let us suppose this is our 5 kN meter movement which is acting in this particular direction. But let us consider if I apply an reaction which is trying to oppose this particular moment, and the same amount of moment is developed in this particular direction. Now this particular object will not rotate. So ultimately it is also in static condition in case of movement also, right? Now I think, guys, you are able to understand what you mean by static condition. Basically, you need to make your object to be in rest, or you can say that the summation of force in any direction should be equal to 0. The summation of forces, sir, it is on comprehensive course. I have already tell you, Pranav, this particular fast track series course is basically a 10 to 12 lecture course in which we will discuss the detail, or you can say that the important topic of your structure part. And if you are able to cover this particular thing, then definitely you are able to solve 3 to 4 marks of question. Means let us suppose if the weightage of the your structure part is 4 to 5 marks in the gate examination, then you are able to at least score 3 to 4 marks from this particular content which we will discuss in our fast track course series. But guys, to be true, you need to practice more and more question. I'm also trying to take cover I'm trying to cover the concept part as well as the question part over here. But guys, my major focus will be on concept first, then later on we will try to solve whatever number of questions we can achieve in that particular lecture. We will try to do it, okay? But guys, it is my humble request, try to approach more number of questions. Kindly watch first video, okay, understand the concept, then try to solve PYQ. You will automatically understand whether you are able to solve the question from this particular series or not. That is the only option you have to understand whether this particular content is useful for you or not, okay? So just do it, है ना? ऐसा करके देखिए, then it will be more beneficial for you, okay? Okay, sir. Now I think you are able to understand what is basically static equilibrium equation. What is basically static equilibrium equation? Okay, let us understand this in detail, okay? So guys, there are two conditions. One is basically, there are two kind of structure. There are two kind of structure. One is basically 2D structure and second one is basically 3D structure. So let us consider this is 2D structure and this one is 3D structure. So first we will discuss about the 2D structure part. So this is 2D structure, which is also known as plane structure. 2D structure is also known as plane structure, bacha. It is also known as plane structure. Plane structure. 2D structure or plane structure. Okay, sir. Now guys, in case of a 2D structure or plane structure, what it means actually, whatever force or whatever reaction is there inside 2D structure or plane structure, all the forces, all the reaction should lie on a single plane. should lie on a single plane. If it is placed or if it is lie on a single plane, then such type of structure is to be considered as a 2D structure for the analysis part. Understood? Let me explain once again. If all the reaction or all the forces which is present or applied on this particular structure is lying on a single plane, then such type of structure is to be considered as 2D structure or plane structure, and we will analyze it as a 2D only, right? Okay, sir. Now guys, in case of 2D, what will happen? Let me explain it. Let us consider this is x-axis and this one is y-axis. Okay, let us consider this is x-axis and this one is y-axis. Now you remember guys, in yesterday class we have discussed each and every axis will have two forces. One is linear force and second is angular force. So you know that if I apply a linear force on x-axis, then it will be Fx, and if I apply a linear force along y-axis, then it is Fy. So can I say that these are the two static equilibrium equation right now for any kind of 2D structure, because both the type of reaction or both the type of forces is lying on a single plane. So we'll consider these two first, then later on we will discuss the different one also, right? So let us consider this one is Fx. This one is what? Fx. This one is Fx force and this one is Fy force. So guys, if I need a structure to be in static condition in x direction or in y direction due to linear force, then the summation of these forces in individual direction should be equal to how much? It should be 0. So can I say that the summation Fx is equal to 0 and summation Fy is equal to 0. Summation Fx is equal to 0 and summation Fy is equal to 0. These two equations must be there for a 2D structure if it is in static condition. Okay. Now guys, if I talk about the moment part, if I take moment about x-axis and moment about y-axis, but these two moment will not lie on this particular plane. Will not lie on this particular plane. Then sir, which type of moment will lie on xy plane, sir? So let us consider this particular axis is a z-axis. Clear? If I apply a moment about this particular axis, then this moment is known as mz. And if you project it or if you see this particular moment, then this particular moment will lie on this particular plane, which is our xy plane. Understood? Kindly observe this particular moment guys, which is about z-axis. This is our z-axis and a moment is applied like this. Then what will happen? If you see this moment will lie on this particular plane, right? So that's why usually you are trying to write down mz or mxy. Mz or mxy. So this is our third equation of static equilibrium equation. That means summation mz or summation mxy should be equal to 0. Then only our structure will be in static condition. Or you can say that these are basically three static equilibrium equation for any kind of 2D structure or any kind of plane structure. And out of which two are linear equation and one is moment part. I think this particular concept is crystal clear to all of you. Please write down in the chat box guys quickly. It is clear to all of you or not? Please write down in the chat box quickly guys. Please write down quickly guys whether this particular part is clear to all of you or not. Okay, it is clear to all of you, right? Now let us consider if we take a 3D structure part. If we take a 3D structure or which is also known as space structure. So guys, for space structure or 3D structure, what will happen? All the reaction, whether it is linear forces or angular forces, the summation of linear force and the summation of angular force in each and every axis, right, it should be equal to 0. So guys, we'll write it down simply. So you can see here, this is our y-axis, this one is x-axis, and this one is our z-axis. Let me write it down. This is x, this is y, this is z. Now guys, in case of 3D structure, the summation fx should be equal to 0, summation fx should be equal to 0, summation fy should be equal to 0, similarly summation fz should be equal to 0. So these are three linear static equilibrium equation for 3D structure or space structure. Summation fz is equal to 0. Similarly guys, all three moment, whether it is mx, my or mz, right? So I will write in this way, this particular moment is what? Mz. So summation of mz or summation of mxy plane should be equal to 0. Similarly, we'll write here summation mx is equal to 0 or summation myz is equal to 0. Similarly, summation my is equal to 0 or summation mxz is equal to 0. So guys, that means in case of 3D structure or space structure, if you want to make it as a means, if you want to satisfy the static equilibrium equation, then that particular 3D structure or space structure should follow all these equations basically, right? That means in case of 3D structure or space structure, we have 6 static equilibrium equations. 6 static equilibrium equation. But in case of 2D structure or plane structure, we have only 3 static equilibrium equation. Only 3 static equilibrium equation, out of which 2 are linear, 1 is angular. In this case, 3 linear, 3 angular. Simple. Clear? Crystal clear. I think this particular concept is very simple and I think all of you know about it, but I had just discuss it so that everyone can understand what is mxy, what is mz, whether it is different or same, like this. Okay? Okay guys, now I hope you are able to understand this particular point, what is basically static equilibrium equation. Okay. Now guys, let us suppose, if you want to read this statement, you can read it. Let me explain one more point over here. Let us suppose if your structure is in static condition or it satisfy the static equilibrium equation, then the part of structure should also satisfy the static equilibrium equation, guys. This is the condition of this particular topic, or you can say that the concept, right? If any structure is trying to follow, or if any structure is satisfying the static equilibrium equation, then the part of structure will also satisfy the static equilibrium equation. And that is the reason due to which you are trying to apply the method of section to find out the shear force, bending moment, or you can say that in case of truss, you are trying to find out the axial reactions or axial forces in the member by using the static equilibrium equation again, right? Okay, sir. So guys, now let us understand what do we mean by indeterminacy and what are the various type of indeterminacy we have and how we can find it out. Okay. Question is, sir, what do you mean by indeterminacy in any kind of structure? So guys, before starting this part, let me explain one simple point over here. Let us suppose if you have any structure, whether it is cable, whether it is arches, whether it is rigid jointed frame, right? Whether it is determinate, indeterminate. If you have any kind of structure, what will happen? There is some external effect or external forces which is applied over it, right? There are certain external force, or let me write in this way, there are some external loading which may be there, right? Or external loading. lateral forces like earthquake force, wind force, right? So lateral forces can be there on a structure. Like it may be possible the support of any kind of structure may get settled down, right? So support settlement may occur, or settlement of support. Settlement of support. Or it may be possible due to weather change, the temperature is also changing, so due to which again stresses may develop in any kind of structure. So we will consider that particular part also, guys, as an external effect. So change in temperature. So these are some point due to which some external effects or external forces, you can say, that are there. External forces are there which maybe behave as a action part. This one is action. Now guys, if it is action, these are basically action on a structure, then structure is trying to develop some reaction also, right? Hello Nayak, come fast guys, okay, and join it. Okay, so guys, if you have any kind of action which is applied on a structure, whether it is external loading, lateral forces, settlement of support, change in temperature, or any other thing, guys, due to which what will happen, this structure is trying to respond. This structure is trying to respond. It will generate some response. Now sir, this particular response in terms of what? This response in terms of reaction. This particular response in terms of reaction. Now which type of reaction, sir? It may be external reaction. It may be external reaction. It may be internal reaction. Internal reaction. It may be slope and displacement. Slope and displacement. Or you can say that deflection, slope and deflection. Better to use this word. Slope and deflection, right? So these are general response which may be developed in a structure, right? And stresses will also develop, we know that, guys. Let us write it down. Stresses, right? So these are basically the response which is developed in this particular structure when you have any kind of action which is applied over it. Now the question is, whenever we discuss, sir, how to analyze, what do you mean by structure analysis and what do you mean by structure part? So structure is nothing as it is the combination of member to transfer the load to the soil or to the floor safely without any failure. That is our requirement from a structure. Let us suppose, guys, if I have this particular stool, right? Now again, this is nothing as, this is basically a structure. हाँ आसिफ, खजाना में recording डल जाएगा, okay? You will get the recording in खजाना, right, after the completion of the structure part in a particular batch, okay? Now listen carefully, you will understand this. Please listen carefully, guys, right? So let us suppose this is our structure, right? This is definitely a structure which have some combination of member. You can see here, guys, there are some horizontal member, there are some vertical member which is combined together to form a structure which is nothing as our stool, right? And what is the purpose of the stool? To sit, right? If I sit like this, then my vertical reaction or vertical forces are getting balance. In such condition, this structure is useful for me, right? But let us suppose, guys, if I try to apply any kind of horizontal force for this on this particular structure or on this particular stool, right, then our purpose will not get fulfilled, right? So you can understand, if you want to use this particular structure, you need to apply only vertical loading on this structure because it is made for that only, right? It is made for that only, to bear the vertical reaction, not the horizontal forces, right? Okay, sir, this is first point. Now the question is, sir, what is structure? So what I am telling you, guys, it is the combination of member to transfer the load to the soil without any failure and that particular in that particular condition it is known as structure. So this is what, again, the combination of member to transfer the load to the soil without any failure. That's why it is known as structure. Now the question is, sir, what is structure analysis? If we apply some load on this particular structure, right, there are certain reaction which is developed at the foot. You can see here, guys, like this. There are certain vertical reaction will develop at the leg of this particular stool. So we need to calculate what is the value of these responses. We need to calculate what is the value of these type of reaction by using some methods or by using some equations. If you are able to do it, then it is nothing as it is our structure analysis. So that means structure analysis is nothing as to find out the response value which is developed due to some external forces or external action part. That is known as structure analysis. Right? Understood, sir. That means, sir, in our structure analysis subject, we need to find out these type of responses. We need to calculate the values of these type of responses due to some external action part. Clear? Now, guys, in this particular indeterminacy part, we'll take two major portion. One is reaction, and second is slope and deflection. So guys, if you know all the reaction part in a structure, whether it is external reaction as well as internal reaction, if you know all the type of reaction, external reaction and internal reaction, that means your structure is analyzed completely. Similarly, if you know each and every slope and deflection value for each and every node, or you can say that joint, then in such case also we can say that our structure is analyzed completely, because after finding out these type of value, whether it is reaction part or slope and deflection part, we need to draw shear force and bending moment diagram so that we can design our structure. Understood? So guys, in our structure analysis, we try to find out all the values of external reaction, all the value of internal reaction, or either we are trying to find out all the slope and deflection value in your structure part, right? So that we'll use these slope and deflection value to find out the reaction again, right? Understood? So guys, we have two choice to analyze the structure completely, either by complete knowing the reaction part or by knowing the slope and deflection value. So in case of indeterminacy, what do you mean by indeterminacy? Indeterminacy is nothing as it is the total number of unknown in a structure. What is the total number of unknown in a structure? Right? So indeterminacy means what? Total number of unknown. Simple. Total number of unknown. Now this unknown can be reaction. This unknown can be slope and deflection value. Okay, sir. So guys, indeterminacy means total number of unknown. Now, if it is related to reaction part, then this particular term, indeterminacy term, is known as static indeterminacy. Then this particular term is known as static indeterminacy. And if it is related to total number of unknown joint displacement means slope and deflection value, right? So guys, it is known as kinematic indeterminacy. It is known as kinematic indeterminacy. Usually, the indeterminacy is represented by D. And if you use suffix S, then it is known as static indeterminacy. And if you use suffix SK, then it is known as kinematic indeterminacy. Clear? So what is static indeterminacy? It is nothing as total number of unknown reaction. Unknown reaction. I will cancel this joint, right? Total number of unknown reaction, whether it is external or internal. Okay, sir. And in case of kinematic indeterminacy, it is total number of unknown joint displacement. Total number of unknown joint displacement. So guys, if we want to find out the static indeterminacy or kinematic indeterminacy of a structure, that means you need to find out the total number of unknown reaction for the static indeterminacy part And for kinematic intimacy, you need to find out total number of unknown joint displacement, right? So in our today's session, we will cover this particular part, which is basically static indeterminacy, which is known as DS. So guys, up to this, if you have any doubt, any query, please write down. Or it is crystal clear to all of you, please write down guys in the chat box. Please write down in the chat box guys quickly. Crystal clear? Okay, Bhanu Prakash. Okay guys. Any doubt, any doubt, any doubt if you have? Okay. So let us understand the static indeterminacy part. What is static indeterminacy and how to calculate it for any kind of structure, sir? Okay. So static indeterminacy, which is also known as DS, which is also known as DS. Now guys, this static indeterminacy is basically, it can be divided into two parts. One is basically external static indeterminacy and second one is internal static indeterminacy. First one is external static indeterminacy and second one is internal static indeterminacy. So static indeterminacy, which is basically DS. Now this per DS value, this DS value can be your related to the external reaction and it can be related to the internal reaction. So guys, if it is related to the external reaction, so we'll consider it as external static indeterminacy. That means the total number of unknown external reaction, external support reaction in a structure, right? So one is external static indeterminacy. And how we can represent it? Guys, again you need to use the same symbol DS, but add one more suffix, which is basically E. So it will become DSE. So this is nothing as total number of unknown external support reaction, which is our external static indeterminacy. Similarly guys, we have internal reactions, and due to which there is one more term which is known as internal static indeterminacy, which is basically DSI. DSI, right? And what is this? Total number of unknown internal reaction. This is total number of unknown external support reaction, which is present in a structure, right? Now guys, what we will do, we'll try to understand how to calculate external static indeterminacy for the structure. Then we'll discuss how to calculate internal static indeterminacy for a structure. And guys, what are the various type of structure we'll consider over here? Let me explain. So guys, we'll discuss both the type of structure, whether it's 2D or 3D. First, on the basis of dimension, 2D structure, we'll discuss 2D structure part as well as 3D structure part. And second thing is, we'll discuss pin jointed structure, which is known as truss, as well as rigid jointed structure. Rigid jointed structure also. So we'll discuss both the type of structure guys, whether it is pin jointed, rigid jointed, as well as 2D or 3D structure. Clear? Okay. Now guys, let us understand how to find out the external static indeterminacy. What is the basic concept, or what is the basic term, basic definition of external static indeterminacy in case of indeterminacy part? Let us understand this. Okay. Okay, sir. So what is our external static indeterminacy? It is nothing as, it is the total number of unknown external, it is total number of unknown independent external support reaction. right? Now what do you mean by, sir, independent? I will explain it, guys, in detail. But before that, just read this particular statement, because this statement will generate the formula, right? It will generate the formula. So guys, you need to remember this statement only, not the formula, because sometime you may find the formula is also getting changed, right? Why it is so, we'll discuss in the example so that you can understand why it is so, right? So guys, external static intimacy is nothing as it is the total number of unknown independent external support reaction. Total number of unknown independent external support reaction is known as external static indeterminacy. So guys, how we can find it out? So we need to write two things. One is basically the total number of external independent support reaction developed in a structure. That means whenever you are trying to apply certain force or external force on a structure, it will develop some reaction, and that reaction should be independent. What it means, I will explain, guys. Okay, so we need to calculate first how many external support reaction is developed in that particular structure due to given loading, then minus total number of available static equilibrium equation. How many static equilibrium equation are available with us, so that we can find out these type of reaction. So whatever remaining value is there, that is nothing as that is basically DSE. Whatever remaining value will be there, that is nothing as that is basically DSE. Now guys, the question is, sir, we need to understand what do you mean by unknown, what do you mean by independent, what do you mean by external support reaction. Sir, what do you mean by develop, what do you mean by available, right? If we are able to understand these type of small words which is available or which is written in this particular statement or context, so guys, we are able to understand this particular definition in detail. Okay, so guys, we'll start with the plane structure first, which is known as 2D structure. We'll discuss plane structure or 2D structure first, and in case of 2D structure or plane structure, we'll cover both, whether it is truss or rigid jointed structure. Whatever formula we will develop over here, it is applicable for both the type of structure, whether it's truss, which is known as pin jointed structure, as well as rigid jointed structure. Okay, sir. Let us take a very simple example. Guys, I hope you remember the different type of support in detail. Let us consider this is hinge support and this one is a roller support. So my first question is, let us suppose if there is a loading which is given to us like this. If there is a loading which is given to given us like this, and whose value is P and this angle is theta. Now tell me guys, in this particular structure, how many external support reaction can develop? What is total number of reaction which can be developed over here? Please write down in the chat box. What is the total number of reaction which can develop over here? 2, 3, 5, 6, 8, 7, 10, kitna? How many external support reaction can develop in this particular structure? Please write down, guys. Two. Okay. Any other student? Guys, it is very simple. Do you remember this thing? If you have any kind of applied load on this particular simply support, you can understand, guys, at the pins or hinge support, we have two reaction. And on this roller, we have one vertical reaction. That means total number of external support reaction which can be developed in this particular case is RE, and it is equal to how much? It is equal to 3. It is equal to 3, right? It is not 2, it is 3 basically. Okay, it is 3. So can I say that, guys, in this particular case, total number of external independent support reaction which is developed, we will write it as RE. We will write this as a RE. RE is nothing as this one. Total number of external independent support reaction, right? And this is nothing as RE, which is developed. Okay. So how many reaction is developed over here? It is 3. Right now you don't know what is independent, what is dependent, sir. We'll discuss it. Right now you are able to understand these are external support reaction which can be developed due to this particular loading which is available on this particular structure. Okay, sir. Similarly, if I ask you guys in this particular case, let us suppose if you have a hinge over here and a roller support, but on this particular structure we have a vertical loading. Let us consider P. Now tell me guys, how many external support reaction will develop in this particular condition? You can see here guys, the structure is same but the loading condition is different. Now tell me how many external support reaction will develop in this particular condition. 2. Definitely 2. That means only vertical reaction will develop. Now we know that this support is capable to resist the horizontal reaction or horizontal action part. But it will not generate any kind of horizontal reaction because there is no action in the horizontal direction. And that's why that horizontal reaction is not developed in this case. And guys, that's why in this particular condition, the value of RE is how much? It should be 2. It is not 3, it is 2. So now you are able to understand why we are writing this word which is develop. Why we are writing this word which is develop, right? Total number of external independent support reaction develop. Now you understand what is external, what is support reaction, what is develop. Now the question is, sir, what is independent? That we will discuss right now. Okay, sir. Now let us take some more example. Now it is clear what do you mean by develop. Okay. Let us take some more example. Let us consider this is our hinge support and this one is a roller support. Okay, sir. And in this particular case, we have a horizontal loading which is P. Sorry, not in horizontal, it is inclined loading P at an angle of theta. Now guys, in this particular case, what will happen? Again, some reaction will develop. At this support, we have 2 reaction. One is vertical, second one is horizontal. In this particular case, we have a reaction which is to be like this. But this reaction will have 2 components. One is vertical and second one is horizontal. Let me name it. Let us consider this is A and this is B. This one is VA, this one is HA. This one is RB, and let us suppose you know this particular angle theta, or let us write it down alpha. You know this particular angle alpha. So can I write here guys, this is basically VB, which is nothing as RB cos alpha. And what about this one? This is basically HB, which is RB sin alpha. Now my question is, sir, how many external support reaction is developed which is independent? Tell me guys, how many independent external support reaction will develop in this particular case? Write it down guys quickly. How many external support reaction will develop which is independent? 4. Okay. So Bhanu says, sir, it is 4. Let me explain why he is saying 4. He is considering VA, then HA, then VB and HB. Now guys, you need to understand why we have written that particular word independent. You can see here guys, if you know the value of alpha and if you know the value of RB, so what will happen if you take the component of RB in the vertical direction, you know the value of VB. In the same way, if you take the component of RB, in the horizontal direction, you are able to understand what is the value of HB. That means, in this particular support, or at this particular support, only one reaction is independent. This one is independent. What about, sir, VB and HB? These two reactions are dependent reaction. So guys, you don't have to consider it again. You don't have to consider it again. If you consider this value is unknown, and after knowing the value of RB and alpha, you are able to get the value of VB and HB easily. That's why in this condition, you need to consider this particular reaction, which is RB, as an independent reaction. Similarly, at this support, VA and HA both are independent. Both are independent. So can I write it down? Now the total number of external support reaction which are independent is basically 3. It is not 4. Crystal clear or not? It is 3. It is 3. It is 3, not 4. These are some small point, guys, which you need to understand. Otherwise, if I tell you the formula RE minus 3, then it is not worth full to understand or to teach this particular topic, right? All of you are able to understand this? Understood. That means the value of RE is equal to how much? 3. But you need to understand which reaction is dependent, which reaction is independent, which reaction can develop, which reaction is not developing. Understood. Okay, sir. Now I think you are able to understand this particular statement completely. Total number of external independent support reaction develop. Why we are not writing unknown over here? Because after using the static equilibrium equation, there are certain reactions which can be known to us, and the remaining part will be unknown. That's why unknown is not written over here. Okay. So total number of external independent support reaction develop. Now you are able to understand how to find out the value of RE. Okay, sir. Now guys, the second part is total number of available static equilibrium equation. What do you mean by it, sir? Let us understand. Now tell me, guys, in this particular case, let us draw it. I will take two cases over here, guys, so that you can understand. First one is beam and second one is frame. Okay, let us take both the cases. Let us suppose this is a simply supported beam in which you are applying a vertical loading like this. You are applying vertical loading like this, and only vertical reaction is developed in this case. So tell me, guys, the value of RE is how much? 3. And this particular structure is what? 2D structure. Why it is 2D structure? What should we do if both support are hinged and one is inclined? Okay, Bhanu. Like this. Like this. So in this particular case, total number of total number of independent external support reaction is 4. Right? It is 4. Because you know that this is our reaction which is unknown, and this one is another reaction which is unknown. So in this case it is 4, not 3. In this case it is 4, not 3. Okay. Clear? Okay. Now guys, in this particular case, let us suppose RE is equal to 3. Sorry, RE is equal to not 3, RE is equal to 2. RE is equal to how much? RE is equal to 2. Why it is 2? Because we know that only vertical reaction is there, or vertical loading is there, due to which vertical reaction can develop as per the Newton's third law. Every action has equal and opposite reaction, and in this case we don't have any kind of external horizontal force, due to which horizontal reaction will not develop in this case. No doubt it is capable to develop the horizontal reaction, but it is not trying to develop it because there is no horizontal loading. That is the reason. Okay, sir. Now tell me, guys, in case of 3D structure, in case of 2D structure, why it is 2D structure? Because you can see here, guys, whatever action is there and whatever reaction is there, it is lying on a single plane. It is lying on a single plane. So can I say that this particular structure is to be analyzed as a 2D structure? This is first point. Okay. Now tell me guys, if you see the action part and if you see the reaction part, what you will observe, basically in case of 2D structure, we have three type of static equilibrium equation. Summation fx0, summation fy0 and summation mz is equal to 0. Now tell me, to find out these reaction, which is basically VA and VB, and let us consider this is P, what are the various type of, or what are the various static equilibrium equation you will use over here to find out the value of VA and VB? Tell me guys, which particular equation you will use to find out the value of VA and VB? Please write down. Which particular equation you will use to find out VA and VB? Please write down guys. Can I use summation fx0 to find out VA and VB? No, it is not possible, because we know that if we write down summation fx is equal to 0, so the component or the reaction VA and VB will not be there in this particular equation. So can I say that guys, this particular equation is not available? It is not available. Okay. But if we talk about summation fy is equal to 0 and summation mz is equal to 0, these two equations are available, because we know that we can write down summation fy0, that means VA plus VB is equal to 0, and summation mz0, that means VA into L minus P into L by 2. So by using these two equations, we are able to get the value of VA and VB. That means these two equations or these two static equilibrium equations are available in this particular scenario. Clear? Okay, sir. Let us take another example. Right now, we are trying to understand the word which is available. Okay. Then later on, we will write down the general formula. Then we'll understand the special condition also. Okay. Listen carefully, guys. Now let us take another example of a simply supported beam. But in this case, our loading is inclined at an angle of theta. So what will happen? All the reaction will develop in this case, vertical as well as horizontal. This one also. Now guys, tell me what is the value of RE? You will write in general it is 3. Right? RE is 3 basically in this case. And what is the equation which is available in this case? Summation fx0 is also useful. Summation fy is also useful. And summation mz is also useful. It is also useful. Right? All three equations are useful to find out the external support reaction. So guys, listen very carefully. Right now you are able to understand what is available, what is not available. Okay. So guys, please try to understand. In general, I'm saying that if you have plane structure or 2D structure, whether it is truss or rigid jointed structure, then in general, we can say that in general, 3 static equilibrium equation is present. 3 static equilibrium equation is present. And our formula to find out the external static interminacy is RE minus 3. I will write it again. DAC is equal to how much? It should be RE minus 3. This is our general formula to calculate the value of what? DAC in a structure. But let us suppose if you have special condition in which loading is vertical, then what will happen? Our formula is getting changed. And in that case, we'll discuss what will be our formula. Right now, I think you are able to understand. In general, what is your formula? DAC is equal to RE minus 3. And what is RE? Total number of external independent support reaction developed. And 3 is static equilibrium equation. The number of static equilibrium equation which is available for 2D structure in general. Yes or no? Please write down, bacha. Please write down. Okay, it is clear. It is clear. It is clear. This particular thing is clear to all of you. Okay. Now, guys, listen very carefully. Listen very carefully. For this particular structure, if I ask you what is the value of DSE, so what you will say? Sir, it is Re minus 3. So how many external support reaction will develop in this case? It is 3. So we'll write 3 minus 3. So it will become 0. That means this particular structure is externally determinate structure. If the value of DSE is 0, then this structure is externally determinate structure. Externally determinate structure. Externally determinate structure. Externally determinate structure. That means whatever reaction which is developed, whatever reactions are developed, or whatever external reaction are developed, we are capable to find it out by using static equilibrium equation alone. That's why it is externally determinate structure. Okay, sir. Now in this particular case, can I write it is Re minus 3? No, guys. We are not able to write down the formula as Re minus 3 in this particular condition. Why? Because we know that this summation fx is equal to 0 is not available. If it is not available, so our formula is getting changed. In general, we will write Re minus 3, but in this situation, we need to write Re minus 2, because one of the static equilibrium equation is not available for us to find out these external reaction. And that's why this is one of the special condition you may find in the exam also, in your practice also, right? So the formula will become Re minus 2 for such condition, right? So please remember this point, and this is the only condition which you find, guys, usually. So this is the only special condition. Let us write it down. Beam with vertical loading only. If you have beams with vertical loading, then in such condition, you may find there are horizontal reaction which is not developing, as well as summation fx0 is not available, right? Understood? So guys, DSE is equal to what? Minimum potential energy theorem, Rohit. Minimum potential energy theorem. But that we will discuss later on. Right now we are discussing the static static Indeterminacy. So DSE is equal to what? Re minus 2. Re minus 2 in this case. Re minus 2 in this case. I hope you are able to understand this part also. Now guys, if you write down the values over here, so what you will find, again this structure is externally determinate structure, because there are 2 reaction and 2 equation, and it is equal to 0. It is equal to 0. Crystal clear or not? Please write down, bacha log, yes or no. Then we'll use some further example so that we can relate it. And in the final, I will explain, as a final context, what we have to do in our examination or in our questions. We'll discuss that as a final framework also. I will tell you about that. But right now, please tell me, guys, are you able to understand what is the difference between these two conditions? Thank you, Rohit. Understood. Very nice, guys. Very nice. Now let us take another example. Listen very carefully. Then we will finalize it so that you are able to understand each and everything. Okay, thank you so much, Bhanu, thank you so much. Listen guys, let us suppose this is a portal frame. Okay, and on this portal frame, let us consider we have some inclined load whose value is P, and again it is at an angle of theta. Now you know that guys, this is a 2D support or 2D rigid jointed frame, and this is fixed support, this is another fixed support. So I think all of you know that at this particular support, how many reaction can be there? 3. At this support also 3 reaction. So let us write it down. Let us write it down. At this support we have 1 reaction, 2 reaction and 3 reaction. Similarly, 1 reaction, 2 reaction and 3 reaction. So can I say that guys, what is the total number of external support reaction in case of this rigid jointed frame which is developing? How many reaction are there? Re is equal to 6. In this case it is Re is equal to 6. Okay sir. Now tell me guys, what is your general formula? Our general formula is DAC is equal to Re minus 3. So we'll write here 6 minus 3, that is equal to how much? 3. That means in this particular structure there are 3 reactions which we are not able to find out by using static equilibrium equation alone, and that's why this structure is externally indeterminate structure, and the degree of external static indeterminacy is 3 degree. That means we need 3 extra equation to find out these 3 unknowns. Simple, right? So we'll write here guys, in this particular case this structure is externally indeterminate structure of 3 degree. 3 degree of external static indeterminacy is present for this particular case. Okay sir. Now let us consider guys, if you have a same type of frame, but in that frame if you have vertical loading, then what will happen? Then I will summarize it so that you can understand what you have to do exactly for your examination purpose or for the question part. Okay, now tell me guys, let us suppose if I have vertical loading. So in this case tell me how many external support reaction will develop at this particular fixed support and at this particular fixed support. Please write down each and every one. Rohit, Bhanu, other student also, please write down bacha. How many external support reaction will develop at the fixed support? Or you can write down the total number of reaction also if you want. Four. Very nice, very nice, very nice, Bhanu. Very nice. Any other student? It is 6 again. That's why I have asked you. Again 6. Again 6. Now I know that you will raise a question, sir, if there is no horizontal loading, why you have developed this horizontal reaction in this particular frame structure? Right? Listen very carefully. You need to understand first what is the difference between the beam and the frame part, and what is the role of horizontal reaction in case of beam and in case of frame. Then you are able to understand why it is developing in this case and why it is not developed in case of beam. Let me explain it. Tell me guys, if you have an inclined load, so definitely a horizontal reaction will develop. But tell me, this horizontal reaction is taking part to bear the horizontal action part only. It will not resist any kind of movement. Yes or no? But if you talk about the vertical reaction will try to resist both the things, whether it's vertical action as well as the movement part. Yes or no? Please write down. While writing the summation mz is equal to 0, you will consider VA also, yes or no? So that means VA or VB, that vertical reaction will also be considered in the movement part, or these two reaction will also generate some movement. First write it down guys, then I will explain the further thing. Otherwise it will get complex. Are you able to understand this particular point? This horizontal reaction is only trying to resist the horizontal force, but this vertical reaction will try to resist vertical reaction as well as the movement part. Okay. The same thing you need to understand in case of this frame structure. Tell me guys, in this particular case, if I write down vertical reaction, this vertical reaction is trying to resist the vertical force, as well as, if you see here guys, if I take any section at a distance of x, let us consider like this. So if you write the bending moment at this particular location, can I say that guys, this vertical reaction as well as this horizontal reaction will also contribute the movement at this particular section? Yes or no? This horizontal reaction and the vertical reaction both are trying to contribute some movement at this particular member, as well as if you consider this member, in this member also you can find out this horizontal reaction is trying to contribute some movement. Getting a point? That's why in case of a frame structure, whether it is truss or whether it is rigid jointed frame structure, whether the loading is vertical or horizontal, whether the loading is vertical or inclined, it doesn't matter. You need to develop all the reaction. But in case of beam, this is the only special case which we have. In case of beam, if you have vertical loading only, then in such condition, kindly ignore summation fx0 and kindly means do not develop the horizontal reaction, right? So this is the only thing which you need to understand, and the rest of the formula, which is Re minus 3, is applicable all the type of structure, right? So let us write down. In this case also, what we will write here guys, Re is equal to how much? Re is equal to 6. So DAC is equal to how much? 6 minus 3, it is equal to 3. Okay sir. So guys, what I am writing here, listen very carefully. Important point. This is very, very important point. So guys, if you have a beam with vertical loading only, then in such condition, what you need to do guys, kindly ignore, or summation fx0 is not available. It is not available. And horizontal reaction will not develop. Horizontal reaction will not develop. It will not develop guys, right? So in such condition, for 2D structure, our formula will become Re minus 2. DAC is equal to Re minus 2. This is the only special case which we have for beam part. This is the only special case guys, right? But let us suppose if you have a beam, or frame or truss, whether the loading, means, let me write in this way so that you can understand. If you have a beam in which loading is inclined loading is there, then you have rigid jointed frame, rigid jointed frame, whether in this particular case, whether the loading is vertical or inclined, it doesn't matter, right? For rigid jointed frame, whether loading is vertical or inclined, it doesn't matter. So let me draw it. Whether loading is vertical or inclined, it doesn't matter, right? Similarly, if you have a truss in which loading is vertical or inclined, again it doesn't matter. You need to write down the formula, which is basically DSC is equal to RE minus 3. And you need to develop all the reaction in case of truss and in case of rigid jointed frame. And this is the conclusion which we want to understand after understanding all the pages which we have discussed in our previous slide. Are you able to understand, guys? Please write down yes or no. If I write down the formula RE minus 3, then it is not worthful for you guys. Until unless if you don't understand these type of points, which is related to the external static intimacy, then you are not able to calculate DSC correctly. Clear? Crystal clear? Now, if you are able to understand these 2 points clearly, guys, that means you are able to understand this definition completely. Right? DSC is what? Total number of external independent support reaction developed minus total number of available static equilibrium equation. If you subtract it, you will get DSC. Okay. So let us solve some question first. Okay. Tell me the answer of each and every question over here. Tell me, guys, what is the value of DSC for this? Write down in the chat box, guys, quickly. What is the value of DSC for this? We have solved it. You know that. What is the value of DSC for this? What is the value of DSC for this particular structure? Please tell me. Please do it, guys. Please do it by yourself. Quickly. It is 0 or not? 0. Very nice. That means it is RE minus 3. So we'll write here 3 minus 3, it is equal to 0, sir. That means first structure is clear to us. Second structure, this is a rigid jointed frame. In this case, inclined load is there. So you know that, guys, 3 reaction will develop at this support, 3 reaction will develop at this support. So DSC is equal to how much? 6 minus 3. So how much it is? 3. What about this truss? What about this truss? What about this truss? What is the value of DSC for this truss? Truss. Only you have to find out the value of DSC, not DSI. Again 0. Very nice, Bhanu. Very nice. 1, 2, 3. So we'll write here again RE is equal to 3 and all 3 static equilibrium equation are available. So RE minus 3, that means 3 minus 3, it is equal to 0. Okay, sir. I am able to understand this also. Very nice. What about this structure, which is frame and with vertical loading? This particular structure is also discussed, right? So we'll write here DSC is equal to how much? Again 6 minus 3, that is equal to 3. This is already discussed. Now tell me for this one, what is the value of DSE for this particular structure, which is a beam, and in this beam one end is fixed and second one is a propped support, right? A roller one. What is the value of DSE for this? Please write down, bachcha log. What is the value of DSC for this particular structure? Zero. Okay, we will understand this. So tell me, in this particular case, one vertical reaction will develop at the roller support. At this support, one vertical reaction, then we have movement. Horizontal reaction will not develop in this particular case because you know that this is a beam with a vertical loading only. Now you know that guys, summation fx0 is not available for this particular structure. That means our formula will become DAC is equal to RE minus 2, not RE minus 3. RE minus 2. If it is RE minus 2, that means 3 minus 2, it is equal to 1. Not 0, Bhanu. It is not 0, it is 1. Understood? Understood? It should be 1, it is not 0. Clear, Bhanu? Another student? Okay, got it. Okay, so this thing we have already discussed and we have written it also. Okay, so leave it. Okay. Now guys, if we talk about 3D structure, or space structure, whether it's pin jointed or rigid jointed, our formula in general will become DAC is equal to again RE minus 6. Right? It is not RE minus 3. In this case, it is RE minus 6. Why it is 6? Because you know that there are 6 static equilibrium equation which is available usually, or you can say that in general, in case of a 3D structure to find out the external support reaction. Right? So guys, in general, our formula will become RE minus 6. So let us solve the question. Let us solve the question directly. Okay. Let us solve the question. Then I will take some special condition for this also, so that you can relate it. Okay. I will take one question, guys, so that you can understand it very well. Right now, this is a general formula. Okay. Now tell me, guys, if this is a truss, which is 3D truss, and you have basically 4 pin support or 4 hinge support. 1, 2, 3, and one of the support is there, which is not, right now we are not able to see that, but it is present beyond this point. Okay. So guys, how many support we have? 4 support. And each and every pin support or hinge support in case of 3D, it will develop 3 external support reaction. Let me show you that. Fy, Fx, and Fz. Similarly, this support will have same reaction, this support will have same reaction, and the support which is available beyond this one is also having the same reaction. So guys, can I write it down? The value of Re is how much in this case? 3, 3, 3, and 3. Total is 12. So DAC is equal to how much? DAC is equal to Re minus 6. So if it is Re minus 6, so we can write here 12 minus 6, it is equal to 6. That means in this particular structure, the external static intimacy is equal to how much? It is 6, sir. Yes or no? Yes or no? If it is so, then please find out the value of external static intimacy for this particular portal frame. Write down, guys, quickly. Find out. What is the value of DAC for this particular portal frame, which is 3D portal frame? Please remember this, okay? You have 3D support. Tell me, guys, what is the value of DAC for this particular structure? DSE. Find out. 15. Okay, Bhanu. Let us solve this. At this support, how many reaction we have? 3. At this, 6, 6, 6. So we can write here total Re is equal to how much? 18 plus 3, that is equal to 21. So we will write DSE is equal to how much, sir? It is Re minus 6. So Re is equal to how much? It is 21, sir. 21 minus 6, it is equal to 15. That means your answer is correct, Bhanu. Okay, 15 is the correct answer. So DAC is equal to 15 for this particular structure. I hope you are able to understand how to calculate the DAC value for 2D structure and for 3D structure. But I will take one more question, guys, which is related to the 3D structure part for beam with some vertical loading. Okay, so that you can understand what will be our formula in that particular case. And that is our last question which we will discuss today. And in tomorrow class we will start the internal static intimacy part. This one we'll discuss, this one. Okay, tomorrow we'll start internal static intimacy. Let me see whether the formula means whether that particular question is available in this slide or not. Otherwise I will write it down. Okay, no problem, we'll write it. Listen, let us suppose this is a wall. This is wall. And through this particular wall we have two beams which is coming out like this. This particular question is already asked in your GATE examination, guys. I'm just trying to write it down. Okay, now guys, let us consider this particular end, and this particular end is completely clamped or fixed inside this particular wall. That means this end is also fixed. This is fixed, and this one is also fixed. But what is happening over here? We have only vertical loads which is applied over the beam, and this particular structure is a 3D structure. This particular structure is a 3D structure, not a 2D one. Okay, now we know that in case of a 3D structure, if you have a 3D fixed support, 6 external support reaction usually develop at each and every fixed support, correct? But in this particular case it is not happening, right? In this case it will not happen. Why it is so, I will explain. And listen very carefully, then only you understand this concept. So guys, what I am trying to do, I will try to draw the axis first. Let us consider this is our vertical axis, y-axis. This one is our horizontal axis, and this is another horizontal axis which we have. There are 3 axes for each and every support. Okay, let us write it down. This one is x, this one is z, and this one is y. Oh, sorry, this one is y. Now tell me guys, right now you have some load, let us suppose W, W and W. Due to these vertical loads, tell me guys, the vertical reaction will develop in the y direction. That means Fy is available, yes or no? Fy is available or not? Tell me guys. Can I write it down? Summation means Fy reaction will develop in this particular case. At this support also, and at this support also, it will develop. Fy will develop. Fy will develop. Now tell me guys, do you have any kind of horizontal action part in this direction so that the horizontal reaction which is Fx will develop? So tell me guys, in this case Fx will develop or not? Because there is no action in this particular direction. So can I say that this horizontal reaction will also not develop? fx will not develop in this case. Can I write it down? Fx will not develop, sir. It will not develop. Yes or no? Please write down here, bacha. Fx will not develop. Yes or no? Yes. Okay. Now, guys, on this structure, we don't have any kind of horizontal loading like this. Horizontal loading like this, which is along to the z-axis, and due to which fz is also not developed. Fz is also not developed. It is also not developed. It is also not developed. Okay, sir. We are able to understand these two things. Okay. Now, guys, you can see here we have a load W, and this W will have certain distance. Let us consider A. Now, due to this particular load W and A distance, we will have some moment which is developing about this particular x-axis. That is W into A, which is WA about x-axis. So, can I write it down? A moment will develop about x-axis, which is mx. Right? So, that means Fy will develop and mx will develop. So, similarly, we'll have mx at this support also. Okay, sir. In the same way, you can understand this W. Let us consider having a certain distance b with respect to this z-axis. So, it is trying to develop a moment m into b about this particular z-axis, like this. Right? W into b, which is WB about z-axis. So, in this case, mz will develop, sir. Similarly, mz will develop. Right? So, we'll write here mz will develop. But what about my? It will not develop. Why? Because if you want to develop my moment, you need some horizontal force like this. Then only it will create some moment about y-axis, and we don't have any kind of horizontal force, and due to that reason my moment will not develop in this particular case. Right? Now tell me, guys, can I say that no doubt this particular support is capable to develop or to resist 6 reaction? This support is also capable to resist 6 reaction, but in actual condition it is trying to develop only 3 reaction at this support and 3 reaction at this support. So can I say that our value of Re is not 12, in this particular case it is 6. It is 6. Okay, sir. What about our formula? Our usual formula is Re minus 6, but in this case it will become Re minus 3. Why it is Re minus 3? Let me explain. Because you know that, guys, there are 6 static equilibrium equation. Summation fx0, summation fy0, summation fz is equal to 0. Similarly, summation mx0, summation my0, and summation mz is equal to 0. But tell me, guys, out of this 6 equation, only 3 equation are available with us, and those are basically summation fy is equal to 0 is available because this reaction is present. Summation mx0 is available because this reaction is present. Summation mz0 is available because this reaction is present. These equation are not available with us. So our formula is not right now Re minus 6, it is Re minus 3. If it is Re minus 3, so our answer will be DAC is equal to 6 minus 3, that is equal to 3. Now I hope you are able to understand. In case of 3D structure also, if you have a beam and you have a vertical loading, then in such condition you need to calculate how many reaction is developed and how many equation are available. Otherwise, if you use Re minus 6 formula, you will get trapped. First जाओगे मेरे लाल. Understood or not? Understood or not? Please write down, guys. Crystal clear? Please write down, guys. Crystal clear or not? It is crystal clear to all of you or not? Thank you, Bhanu. Thank you so much. You have understood it. Okay, very nice, very nice, very nice, guys. Very nice. Now, I think you are able to understand how to calculate the value of DSE in case of 2D structure and in case of 3D structure. What is the formula, or what is our uh, value which may get changed in our formula, guys? You need to understand this, and we have discussed it in detail with some example, with definition, and each and everything. Okay. Now, guys, we are stopping over here. Now, tomorrow we'll start this particular topic, which is basically internal static indeterminacy, and then we will try to solve the question also. Okay, so tomorrow at the same time we have a class in which we will discuss internal static indeterminacy, or we'll start this particular topic and we will solve the question also. Okay. Okay, guys, I hope you are able to understand each and everything which we have discussed in this particular class. And guys, I hope you have loved it. Okay, any doubt, any query, if you have still, guys, please write down. I will explain. Otherwise, we'll close the session and we'll meet tomorrow at the same time. And thank you so much, guys, for joining it. And let me tell you one thing more, guys. You can join my Telegram. You can join my Telegram so that you can get the link of this particular type of session as well as the PDF of this particular session. You can search my name, Krishna Yadav Sir PW. Kindly type this. You will find out my channel on Telegram, where you will find the link of these type of session or upcoming lectures as well as the PDF of this particular lecture. Crystal clear, guys? Any doubt, any query if you have? Any doubt, any query if you have, please write down. Okay, guys. So thank you so much. Thank you, Bhanu. Thank you, other student also. Thank you, Aditya. Okay, let's meet tomorrow, guys, at the same time on the same YouTube channel, which is 𝐂𝐤𝐬𝐴 English YouTube channel. I hope you are able to understand each and everything which we are discussing in this particular class, and I'm trying to put my 100% effort so that I can explain each and everything, right? My major concern is to clear your points, or to clear each and every concept which is related to the topic in detail, right? Not in short, in detail. That is our requirement. Okay, and that is our promise from 𝐂𝐤𝐬𝐴 also. Okay. Okay, guys, so thank you so much. Let's close it and let's meet tomorrow at the same time at 6 p.m. Okay, bye bye, take care, guys, and let's meet tomorrow. Okay. Okay, Bhanu, thank you so much, guys. Let's close it. Good night and take care, and revise it and try to solve the question which is related to the external static indeterminacy part only.